So, hello everyone. This is the third session of DSC WOW today, and we have Fireside chat with Rachel. Who, of course, this is not the same kind of fireside chat we are going to expect from what there's in like US presidential elections. There's something like different to it, so don't consider it to that as well. So, Rachel, who is currently working as an applied scientist at Amazon Web Services, she has also worked in the field of fintech, primarily in the field of portfolio management and global tactical asset allocation. She has also worked in the field of investment banking, etc. And she has graduated from University of Waterloo and has completed from University of California, Berkeley. So before we begin, like Rachel, two words from your side. Like, could you you know yourself better? So, what exactly? How do you define yourself?
Well, thank you, Harsh, for introducing me. And it's my pleasure to be here and chatting with you. So I just talked about my name is Rachel, and I'm an applied scientist at AWS, Amazon Web Service. So you probably haven't heard applied science before. So you probably heard data science and research science before. So basically for data science, they focus on like gathering more information from the data and to get more insight from the data, and they have a lot of messy data they need to work on. Well, on the other hand, research science will focus on maybe building more innovative models from any data set, like from any public available data set, like ImageNet. So applied scientists would be in between of these two positions. So at Amazon, we are really applied company. So we want to apply most of the state-of-art techniques to the products, to the service. For example, if you go to Amazon.com, like if you search anything, there will be a lot of items coming out, a lot of commodities, and that will be a recommendation algorithm working behind the scene. So that's like how do we try to do the ranking, do the recommendations, and apply all those techniques or those machine learning methodologies behind the scene. So applied scientists at Amazon is like we have some data like customers data, and we want to apply like those really state-of-art methodologies from the papers to the product and to benefit our customers. So that's like the maybe applied science definitions at Amazon. And so for my job, like our team is like the open source team. So we are working on those weeklong open source kind of framework. And if you have learned deep learning, probably heard of like TensorFlow, PyTorch, MXNet, and weeklong is kind of an easier wrapper upon everything. So it will be easier for any starter level of students or any enthusiasts for deep learning to start with deep learning. And as for me, my own project is mostly on the education for deep learning. So one of my project is called DTL.ai or Dive into Deep Learning. So it's an online interactive notebook or interactive book that it contains 140 Jupyter notebooks and includes all the three major deep learning framework include MXNet, PyTorch, and TensorFlow. So if you go there, you can learn the math, you can learn from the text. We have all the visualizations, and you can play with the code by just hit the case there. So that's all of my work, and sometimes I also teach part-time at Amazon. So inside Amazon, we have this machine learning university. So I also teach our engineers there. So that's a little bit of myself.
So like that's a kind of really tedious work you handle at Amazon. It's not kind of an easy task that everyone could actually handle. So like, yeah, moving on to Harsh now.
Yes, so that's interesting. I was actually going to ask you that as a first question because I read the job description on the AWS website, and it was very interesting because it seems like one of those jobs that you don't know exists while you're studying for it. So it felt like one of those jobs to me. I think I'll move on to the next question. In recent times, machine learning has become arguably one of the most trendy buzzwords in the freshers industry, especially. with some people claiming that there will be millions of job openings in machine learning and the data sector in the subsequent coming years. Having worked in this industry for a while, this statement that AI and data will create millions of jobs in the future, how much of this statement do you think is actually true? Like, are students forcing themselves in vain to study ML? What do you think about that?
Yeah, that's a great question. Well, so first of all, I won't say that for anyone who wants to get into the machine learning industry, they need to force themselves to study exactly ML. So ML is kind of the combination of computer science, mathematics, and probably a little bit of domain knowledge, especially if you're going to working on some bioinformation data or some medical data, or if you're going to working on the NLP data, you need some linguistic knowledge. So you probably need a little bit domain knowledge for that. But I would say, like, in general, I don't think like it's like forcing you to learn the knowledge. It's like, for me, like I studied pure math back into my undergrad, and what we learned is like real analysis and big measurable, like the big integral, etc. So like for my work now, there's no one really ask me to prove some theory for them, right? I do not need to write down the whole theory. So do you think that is not useful? Well, probably if you just define by if you're not like write the proof itself, it's not useful. But I feel like it's really powerful. Like math itself is really powerful for me, especially when I read a paper. I can easily get the idea of the paper. Like I can easily follow the mathematics behind the scene. And also, even though back in the real life, a lot of things, a lot of problem needs some logic, and the mathematics logic, it's really the fundamental background that we need to build, and that really helped me a lot. That's like my seventh sense. Like it just like give me some intuitions when solving the problem. So I don't feel I agree that there are lots of buzzwords. I remember back in 3 years ago, first time I came to San Francisco for my first data science job here, and I got an Uber, and the Uber taxi talked me a lot, discussed a lot about machine learning, and it's super powerful. It will replace our drivers, and he was like super worried. And I feel like, oh my god, machine learning is really a buzzword. I don't think it will be replace a human, to be honest, in a really short future. Yeah. Hopefully answer your question.
Yes, it surely does. Okay. So I'm also very curious to know how this will affect the final decision of the people going forward, a conversation that we just had. So the buzz going around the data sector, as you mentioned, there's millions of courses out there, there's platforms, and there's promises to make you an able data scientist in, let's say, 3 months, or in just one single course, to, as a matter of fact. So what I feel, what I've experienced myself, is what no one teaches you is how to go ahead mastering that field. There's a lot of courses on the basics and how to get fluent with that, but there's no course on moving ahead. So how would you advise a student who's already fluent with the basics to move forward with the self-study of machine learning, which according to me counts as a major part of the study? Like you'll have to self-study if you want to master something like machine learning or data. So how does one do that?
That's also a question. So first, I really like your enthusiasm in studying machine learning or deep learning. So I believe there are two main parts for this question. So there are many subfields of machine learning, and we have to agree that we cannot study everything. We cannot be master at everything, every field. So for a CV expert or a computer vision expert, he or she probably do not know a lot about NLP. So we have to agree about that. So first, I believe that everyone needs to find a direction that where he or she wants to dive into, no matter NLP or CV or graph theory or speech or time series, robotics, reinforcement learning, etc. So you need to find your direction where you want to go, and especially find what you like it the most. And I feel like the enthusiasm from ourselves, the motivation from ourselves is more important, because if you feel like you like this domain, you feel like you're gifted and you're even eager to learn more in this domain, you want to learn more, and you feel you're talented when you're trying to read new papers and draw new models, it's really a great feeling. It's like a flow feeling. So find your love in some domain and then dive into to learn deep learning. And after you find it, then move into next directions. How do you learn it? How do you be a master in this domain? So you probably need to read the most prominent papers, like go to Google Scholar, check like the most cited papers and read most of them. Like you will be understand like what are the main fundamentals in this domain, right? And at the same time, you probably need to follow the trend of this domain because like for each domain it's kind of momentum moving, especially what are those top researchers, academia researchers or industry researchers are working on right now. What are their topics? They probably talk a lot on their Twitters or probably on their like course website, on their publications, on the latest workshops in the top machine learning conference like NeurIPS or ICML, etc. So follow the trends in that domain, and probably at the same time find a mentor or like a study group like you guys, like study together and engage each other would be super important as well. There will be creative virtuous cycles for you guys within your guys. So that's probably my general advice.
Yes, ma'am, that's very insightful because most of my friends are just stuck in that loop. Some are doing theory, some are doing just coding. So I feel like that will help us to break out from that. Okay.
Yeah. Hi, Rachel. As you talked about data, like you take the data and you use it to apply it to the data for your the learning teaching purposes and for in your day-to-day work, right? So data is becoming a very huge. Data is expanding in a very high rate, right now, and big data is a buzzword as well with the machine learning. So how in AWS and how in AWS do you handle such a huge amount of data, and how do you think people or students should go about learning handling these huge data sets?
Yeah, that's an awesome question. So first, I agree that the data is exploding nowadays, and more institute, companies, even individuals are collecting, analyzing, finding insight from the data. Well, on the other hand, you need to be capable to query and analyze those large scale of data sets, probably using Cycle or using Spark, etc. So you probably also as a machine learning engineers, you probably want to train some machine learning models using some distributed training. So you need a lot of GPU to train together. So the scale of distributed training probably also be helpful. So I believe there are a lot of online resources available to teach you how to like distributed training, how to Spark, how to use SQL, etc. And I won't mention too many names here to avoid being like advertising here. Well, on the other hand, in academia, there's a research trend that is moving towards the era of like one-shot learning or zero-shot learning. And this means that we want to use less new data as possible, but apply some transfer learning techniques. So which means like those models have been already learned from a huge data set before, and we just grab this model, this architecture and the weights or the parameters inside the model, and we train on the small new data set, and we want to transfer how to learn the new features or new insight from the new data set. And the transfer learning is super powerful because it's computational friendly and it's environmental friendly. So I feel this is kind of a trend in academia and also in industry, because like most of the companies, they won't have a huge data set. Like besides like the big tech companies, like a lot of other companies don't have the huge data set. So how they grab insight, and that will be the research trend.
Yeah, that is true. Yeah, that answers that. Like it is a very diverse field, right? Handling data set. It is the research is going on right now. I've read about transfer learning and the data handling methods and all. Yeah, that would be very useful for the students right now. So next I wanted to ask was about privacy. Like privacy is becoming a major concern in today's world. where the tech giants, they hold almost all the user information, right? These informations increase when like these concern about this information increase when we talk about using them in machine learning and deep learning. So how can you tell us a little bit about how AWS handles this sensitive and private data, and how can students learn more about data privacy, especially when we talk about machine learning?
Yeah, that's an awesome question. Like, I'm glad you asked for this topic. Actually, privacy has already become super, super important from the past 5 or 10 years, especially after data is becoming collected. But I want to clarify first, even though AWS have lots of customers, it doesn't mean like we have all the customers' information. Like, it's still controlled by customers themselves. It's not controlled by AWS. Customers have their like full control to have the access control, security control, who is going to access data, etc., who is going to transmit the data to where, etc. They have the full control. We just provide the server to them. It's just a service. It's not a control. So even though for customers' information, like who is our customer, we still have the agreement with our customer. If they do not want to disclose their name, we cannot do that. So that's like our agreement with customers, because like customer trust is always our top priorities at AWS. And so how do we provide our cloud privacy? We have those like cloud adoption framework that will provide customers guidance and the best practice to help our customers understand like the whole overarching approach to cloud computing across the whole organization about privacy. So within this framework, we focus on security and privacy a lot. For example, there are such like this several few domain like the IAM, which is AWS Identity and Access Management, that customers can control, can define who's going to be the user, who can access which service, who have which kind of function, like you can pull the data or you can push the data. So we all have those like list of JSON defined that each customer can define the security themselves. So this is IAM. And we also have the detective controls. We also have like the infrastructure levels, securities. We also have the data protections, etc. So that's all the different kind of frameworks that we try to build the whole secure environment for our customers to preserve their data privacy. And as for your second questions, how do students learn this privacy? So back to my graduate studies, I follow a lot of like talks, like panels, like from the academia. So back to Berkeley, we have those like whole week panel called differential privacy panels. So back into the Simon Institute of Studies. And so there are all researchers around the world coming to there, and they talk about differential privacy. So that's one of the kind of momentum to preserve the privacy. Also, federated learning is another method, which we have all the data in different ways, and we don't grab the data there, but we learn. We just keep the data there, but we use federated learnings to learn the features from each of the own device data, embedded data. So I would say that's another method. But if you want to learn, I believe there must be some courses. I know that Berkeley have privacy courses. I forgot the number of the course, but you can just search, right? You can just search like differential privacy or federal learning or just data privacy, and just search like different universities, like Stanford, Berkeley, like those schools which have a lot of machine learning expert, and I believe you'll find your answer.
Okay, thank you.
Yeah.
So it's differential privacy and federal learning, right? Federal.
Yeah. I'm not to be honest, I'm not a privacy. Like privacy is a huge field. Like I'm not a privacy expert, but that's what I know. Like differential privacy is definitely it's kind of the crucial field in privacy. So I believe if you want to learn that, and that is a must-know thing, and also federal learning is kind of another way that researchers are using, especially industry researchers try to use it to solve the question.
Okay.
Yeah, and also you can maybe follow some of like the
follow Andrew. and to trust.
So, yeah, exactly. Like follow this top research, like online classes, or follow those like top conference. Like for the conference, they have the workshop, and the workshop always show you the top trained in different fields, and all the expert like in that field will probably hold the workshop.
Yeah. Thank you for that. I wanted to ask, like you mentioned that machine learning is not only about core machine learning concepts, right? So, what are some of the core computer science concepts that you utilize in your day-to-day work, and you think that students should be well versed in when we apply for jobs in machine learning or applied scientists?
Well, that's a great question. So, I would say like I'm coming from like a master's stats background. Well, I would say like back to my I'm a little bit lucky because back to Waterloo, like computer science is within math faculty, so we are forced to learn those like fundamental computer science course. So even though I did like a statistic and mathematical finance background, I still learn a lot of computer science and feel like it's super powerful, super useful in my nowadays job. Like I believe you must know like the complexity, like the big O, right? It's like O1, ON, like what's the difference? Why you're using one rather than another? And also, I would say memory, like the virtual memory, space, or garbage collections, like those around of topic, like how to have those memory control would be super, super useful, I would say. And also, I believe operating system and compiler would be useful, but that's probably a little bit far from like the machine learning research side, probably a little bit closer to machine learning framework side if you want to do more of a framework. And also some concept of distributed training, like using different process, like the running instance of the code, or concept of compilation, thread process, etc. Like those probably some concept you need to be aware of, because machine learning is kind of like computer science plus that. Like you need to let the computer or let the machines run, right? And you need to let it run efficiently. So you probably need to spin up a lot of machines to train it quickly. So that's kind of my idea from computer science wise. But if you're talking about like machine learning concept, there will be another whole bunch of concepts. Yeah.
That is true. What do you think about like data structures and algorithms? Like, are they very useful in your day-to-day work?
I would say definitely yes, because that's like back to our first topic when we talk about like whether math is useful at all. It's like the basic idea. It's like the whole data structure. It's like when you programming the code, like the whole data structure will help you build the fundamentals, like to help you to efficient program. It's like to help you solve the question. So I would say like those are the fundamentals. All the fundamentals are still important.
Okay, yeah. Thank you for that. That was very insightful. I also wanted to talk about like how exponentially the machine learning and AI field has grown in the past few years, right? Nowadays, if you want to build a state-of-the-art performance for any technology, you need to apply some kind of artificial intelligence to it. So, in your opinion, how widespread do you think the field will become in the coming years? And should all the students in this field need to learn the core concepts of AI to keep up with the advancements? Like, if do all the computer science students need to learn AI in the future because of its all around usage?
Great question. That's a really interesting question. So let's take a step back to the whole technical revolutions in the human history. So even though AI looks like a super, super new, super powerful technologies, it is still just a new technologies and still following the similar pattern like the computer science revolutions, like the dot-com bubbles back into like 30 years ago. So back in 30 years ago, do you think a lot of students knew a lot of concept of computer science? Probably not, right? And how about now? It seems like a lot of students learn and study computer science, but we cannot force all of the students to learn the core concept of computer science. So that's a similar pattern we apply for artificial intelligence. And now I believe it's just the beginning. It's just like back in 30 years ago when students still picking up computer science. So you guys are at the right era, at the right train. And I would say a great metaphor for AI would be the ability to drive a car. I would say that no one will force you to learn how to drive a car, but you probably do not, and you probably do not need to drive a car if you're living in like New York City. It's like there are lots of traffic jams there. You probably do not need to drive a car. But in general, if you want to get somewhere more efficiently, it's probably there's a higher chance you need to learn how to drive. And similarly will apply for AI because it's like learning from the data is much more powerful than you just like using human knowledge to programming, right? It's like the expert system, like you need to code it line by line. But using AI, you just learn from data. And I believe that is much more powerful than just we do it. It's just like you previously you walked by your feet and now you're driving by the car, right? Yeah, it's just a tool, I would say.
Yeah, that was very insightful. Thank you for that. Sorry. Nice metaphor. I'll use that.
Thank you so much, Akira, like for your about importance of Kaggle in future hiring process and learning process, because Kaggle is something that is kind of increasing exponentially day by day. The number of people, the number of people applying those skills, the number of competitions, and it has been proven that many of the people who are actually active on Kaggle are bagging these successful kind of jobs as data scientists or applied data scientists or machine learning engineers and experts. So what's your viewpoint on like these platforms which are gearing up for like the future generation?
Yeah, great question. So I believe if you want to study for like academia, especially for graduate study, or if you want to be a professor in academia, and like Kaggle and other academic leaderboards are a great place to go. Well, however, if you want to work in industry, especially if you want to build some really flexible models, training the great models probably not enough. I would say like in industry, like probably 10% of your time or your whole project will be training the models, and another 90% will be like building the whole machine. It's like building the whole machine learning pipeline. It include collecting the data, maybe like do the cleaning of the data, you're right, and do the data visualizations. And after the data is cleaned, the features clean, you train the models, and then you move into deploy the model. It's another hard part and making the model works, because in industry, you do not only care about the accuracy of the model, you care about, for example, at Amazon.com, we care a lot about latency. Think about that. We have like 99% grade of like recommendation models there, and we have another 95% of models there. And then the 99% of model will need 10 seconds to do the inference, and this 95% of models will probably need like only 1 second to do the inference. And if you go to Amazon.com, you search a query, and you need to wait 10 seconds to find all the recommendation comes out. Do you feel like you're happy with this 99% of accurate models? Probably are not, right? So I feel like that's kind of the biggest kind of realization after I left academia and came to industry. I feel like they do not care about like the model performance itself that much. They care, but they do not care a lot. Like in Kaggle, you only care about your place, right? You're the first place, the second place. You do not care like how long. Like it's like huge ensemble model on Kaggle, right? It's always ensemble models for the top maybe 3 or even 10 place, right? And those are also models take super long time to do inference, to run it, to do predictions. So probably it won't be that much applicable to wait a model like 10 seconds to show everything. That will be a super painful experience. So I would say like it really depends on your choice, like whether academia or industry, and it depends on the job function or the model's needs. So there are a lot of things. Like as for deployment, there are even more things to think about, like the size of the model. Like now we do a lot of for our group, we do a lot of distillations. So after we assemble those models, we distill like or tune like those weights or those leaves. They are not important. I just distill on the whole trunk of the models. So it will be much smaller, but it still have high performance. Also, that's I would say another trend in research. And so there are a lot. Like after you deploy, you still need to monitor it. You need to maintain it. You cannot just leave the model there. It will just like the model drift. Probably everyone heard of like after like the model being trained, it will just the performance it will going down, right? Because there will be new data coming in. There will be some data shift. Like the distribution will shift, right? And you have to keep in retraining. So building the whole system and running the system, maintaining the whole system will be another huge topic coming to industry.
So yeah, like there's a lot to learn and well right into it, because academia and industry are like two poles apart, I guess. And we like it's a kind of an non-ending topic. How exactly should we proceed towards academia or towards research and towards industry? So like moving on to my next question. Like my next question is, what do you think about the level of mathematics required in the field of machine learning and artificial intelligence? Because some of the researchers and academians like Andrew Ng says, don't worry if you don't know it, you'll know it. But at the same time, some people feel like AI is something more of comparable to quantum physics, where you need to like keep applying and learning things at the same level of how a quantum researcher applies.
First, I'm not a quantum expert, so I won't talk anything about quantum. But I feel like even though Andrew say that, and even though I say that a lot back into I'm teaching there, because I feel like after you leave academia for a long time, you probably forget a lot of the math. That's a general trend. But I feel like math is still important, especially if you really want to work on like the most state-of-art trend. If you want to follow the trend of the research side in machine learning or deep learning, I would say there are several domains like linear algebra, like calculus, no matter single variable calculus or multi-variable calculus, and statistics like bias wires trade-off, like the maximum log likelihood, etc. Distributions like binomial distributions, Gaussian distribution, multinomial distributions, exponential family in general. So optimizations like gradient descent, stochastic gradient descent, etc. Like how to optimize a model. It's a fundamental topics in deep learning and probably a lot of machine learning. And information theory is like how do we apply interface? How do we calculate mutual informations? Like especially if you want to learn reinforcement learning, like KL divergence is kind of building on information theory. So I would say like those are fundamental knowledge you probably need to understand and really deeply understand. It's like not you today you understand it, tomorrow you understand it, and then next week you forget of it. So it probably I feel like this is kind of reinforce yourself to learn. Every time you kind of read a new paper, coming in a new topic, you feel like, oh, this is a concept like you can play here and also other place. So I would say just like the basic math. I would say those probably there are more. I forgot, but there are the basic math here that I would suggest everyone who wants to get into the field of machine learning or deep learning to learn. These are just really shallow domain of math. It's not even real analysis, right? And if you really want to learn the math for deep learning, like back in last year, we write DTL, we write a chapter. So me and another scientist at Amazon, we write this chapter about math for deep learning. I can send you guys a link afterwards if you want to learn the fundamental math for deep learning.
Yeah. Oh, like that's great. That's great. Getting links of
yeah, that would
Rachel.
Yeah, that would be include all the link with code. Like we have the MXNet, TensorFlow, PyTorch code for apply this math model. But I would suggest you to try to implement yourself after you look at those mathematics logics, and that would be super helpful.
Yeah, great. So there's a lot of commotion today. If it would have been a kind of physical event, we could be like having out pizzas and coffees together, but it's not a physical kind of virtual event. So, yeah, so moving on to my next question, like what are the common problems what future AI enthusiasts and practitioners might face in their transition journey towards becoming machine learning engineers, experts, and data scientists? And what should one not do to become in order to become a successful data scientist? Because most people ask, what should I do to become a successful data scientist? But my question is, what should I not do to become a successful data scientist? Because of talking of my journey, even I feel confused. Like there are diversified fields. Like yeah, as a student, I feel where should I exactly should I proceed in CV? Should I proceed in NLP, speech, time series? Like what do you think about all these questions?
Yeah, I like how you asked this question. Like you asked now to do rather than what to do, because tons of authors have been already aligned what to do to be a data scientist. I feel with this question, you need to know what do you want to gain from this position, right? What do you really want to do? Because data science, like this field, I would say, is really, to be honest, a little bit buzzword now. It's like data science for different company, different position, different team. It's like totally different. Like I have some friends back working at Facebook, and data science at Facebook is majorly working on SQL and do a lot of analysis. So if you really enjoy finding insight and doing analytics, probably that would be the right position for you. And you just like think about when you were there. Just think about your data science. Like when you were there, you have to try to analyze it. And what do you need, right? And think about from the end and going from start to learn what have the techniques that you probably need for this job, for this project. And I would say like working on some project will be super helpful rather than just reading the books or reading other people's interviews, like the common 100 ask interview questions or whatever thing like that. Like don't just read, but just do it. Because when you just imagine yourself as a data scientist now, and you are going to work on it now. Find a project working on it, and you will know what you are missing, and you will learn from it. And I would say so that's like just one aspect for data science, just like doing SQL, and there are also other data science. Like for my first job, like when I was a data science doing in startups, we're doing a lot of NLP there. I would say like in industry, especially if we're working in a startup, probably you will have a lot of time working on getting the data. Like getting the data, building the whole pipeline is super kind of hard job, to be honest. But if you're going to like more like larger corporations like Amazon's or like other companies, then probably it's more well structured, and you know like your team will all focus on the similar things. Like for example, our team's more focused on the framework, like the deep learning framework to build the compilers for deep learning. So it's like a little bit different for different companies, different positions. You first probably need to understand what do you want rather than follow others, rather than just read others' experience. Know what you want to do, and find a job. Do not just find by the title. Sometimes a lot of data science do not call data science. They probably call applied science, right?
Yeah. So that's really total. Like there's this thing what people say. You don't learn swimming by reading books. You learn swimming by jumping in pool. So that's a really true situation, like what you exactly pointed out here. So learn by doing is the actual translation process. So like just before we end, the final trends right now, I guess, are computer vision, NLP, speech, and time series. So word of advice for people who are like trying to get into these four fields.
Get into this full field. Can I clarify?
I am kind of talking into like I don't know about what exactly in US is, but in case of Indian scenario, the companies offering job roles, etc., are like currently in mostly in these profiles. Like it's in computer vision, natural language processing, speech, and time series. And the last one, which is right now coming into India, is kind of fintech and data science. So these are kind of fields that are coming into the transition. So like you have already practiced most of the fields. So I guess word from advice would be kind of helpful to the guys who are like stepping into their shoes of transitioning their journey into specialized fields.
I would say like still find what you love. Like no matter, even though it's not between, like it's not among those four fields, find what you love first. Find what you feel like you'll enjoy. Like if you're enjoy linguistic knowledge, you probably will go to like LP, right? If you fancy, if you're a photographer, like you're part-time photographers, if you really like drawing, etc., you probably can go to CV, right? And I would say it's really finding what you love as the most important thing. I would say like I did finance, like I did a little bit like quant before. It's quantitative trading in finance, but like to be honest, I feel like myself, I do not like finance a lot, so that's why I'm moving out. But after like that's why I feel like probably at you guys' age, you can try different internships. That would be super helpful. Try different positions. Like back in Waterloo, we have this co-op program. Like we have to do 6 internships before graduate. So I did like those different internship and find what I really like. Is like I really like doing data science. I really like doing these models and make it super insightful for users. Think about that. It's like really improves efficiency a lot. So that's what I'm passionate about. But I feel like different people probably have different passion. So finding what you're really passionate and join that group, join that circle. If you are passionate, join that circle, and you will have a group of amazing people working with you, and that feeling is awesome.
Thanks.
Ask about
Yeah, Akshita, go ahead.
Yeah, thank you, Harsh. I wanted to ask, like you said that you were in finance and you transitioned into this computer science field mainly. So was that transition like what were the challenges that you faced during the transition? Like I'm very curious about it. Because not many people try to change the field they work in, right?
Yeah, totally. That's a great question. So I would say it was a little bit people, to be honest. Like I self-study a lot of courses. I self-study all those back into like all those machine learning course and deep learning course. I self-studied because it's not under my majors. But I feel like it's still connected because both quantitative trading or quantitative finance, quantitative portfolio management is still like kind of have the similar fundamental as deep learning. It's like all they are using the similar optimization theory, similar statistics, similar distribution, right? The Gaussian distribution assumptions. So all those maths are similar and all the programming is similar. So quant need to program in all those quantum tradings, right? So I use Python a lot already back into my previous fintech job, and then moving to data science, like you still program the similar thing, you just apply on different data sets. Well, you probably need to know a little bit domain knowledge. Like for me, when I move into data science, I learned a lot of NLP knowledge, like latent semantic analysis, like those kind of like pattern modeling, etc. Like only in NLP or derived from NLP. So I have to learn those kind of like domain things if you want to be a data science in one domain. But I would say like, it really depends on your enthusiasm. If you have that motivations to learn, it's not that hard, right? It's like you always enjoy the learning, and being a data science is just the result. It's just like the set product after the whole progress.
Like it's not hard to kind of learn these days. It's more harder to find motivation these days.
Well, don't put yourself in a lot of pressure. I would say now, while looking back to myself, like when I was working at finance, I always felt I'm under a lot of pressure. And after I'm moving out, I understand because I do not like it a lot. That's why I feel a lot of pressure. If I like it a lot, probably like I will enjoy all my daily work, right? I will be super engaged every day. So that's like different about for different people. So just find what you love.
Thank you. That was
But anything from your side?
Not really.
Yeah,
I don't
for the
lie.
final
Exactly.
edit.
So do in today's world, you done deep learning.ai wala deep learning specialization course you've done. So do you think courses actually matter? Because there's a fight going on LinkedIn right now, which I regularly see. That there's people arguing that certifications don't matter. There's people arguing you should do projects. And there's people slandering others for highlighting the certifications and everything. So what do you think about that? Is it actually important, or should we just focus on the learning and then go over to our projects?
Oh, great question. So I would say I learned didn't mean that like I want to be a deep learning scientist, etc. It's I feel like that is kind of people are talking about it, are just interested in it. And as I just said, like getting the certification is just like the side product after you learn it, right? Like it's not your final goal to get just a certification. So I feel like my thought is there are a lot of this kind of similar course going on. You can try different. I try a lot different deep learning course online, like no matter the deep learning course from Stanford, from Berkeley, from MIT, etc. So like I try a lot. I feel like they all have some like new things when you try new course, but you kind of like review a lot of contents, which is a good process. But I felt this is just one type of learning. If you really want to be like data science or machine learning engineers, like you probably want to implement the code yourself, like practice more rather than just sitting there and learning, because you want to engage yourself to actively learn. How to engage is either you asking question, keep asking question, or keeping like try to extract some knowledge from your brain, which is to coding, like code anything or like implement to any like product anywhere. So I would say like to extract the knowledge from your brain, no matter whether you just have like another friend, you just talk to him or her about what you learned, that are also helpful. So just try to extract different knowledge and try to connect different knowledge you learn and from the course itself. And again, getting that whatever certification is just a side product.
Right. That makes sense. So continuing with that question in a way, talking about your resume, what would you highlight on a resume? Like I'll be going for my master's probably next year July, so I have to submit my resume as a profile to many colleges. So what do you think I should highlight and to everyone in just a data science profile? What are the main things that a person should show to, in a way, prove his or her expertise in the field?
Great question. I would say so first it would be super different for different job positions. So probably for different job positions they have different requirements. Like for example, for one of my partner team, they're focusing a lot like machine learning university. They focus a lot of teaching. So probably when we find as a candidate someone who teach a lot at their graduate studies, we're probably we prefer them a little bit better because they have this kind of experience. But this is our bias for this position, right? If you go to another position, they probably need someone who have trained a full pipeline machine learning model before, and they would like to prefer that kind of experience. So I would say like I'm not quite sure how's the data science trend going in India, but you probably know more than me. And find a position and highlight your knowledge or your skill set based on that position.
Right.
Yeah, that would be my general advice. And I would say like for me, I would really prefer someone who has some unique skill set, like some skill set I do not even have. Like no one knows everything, right? If someone came in, be my coworker, and I can learn from him or her, I would be super, super happy.
Right. That makes a lot of sense.
Like one prominent thing, like I have observed in India, like where companies do come in for these associate data science or data science roles. They hire on the basis of knowledge, on the expertise of level in deep learning, NLP, and etc. of these things. But later, when people do join in, most of the practitioners start end up working on Excel and SQL rather than actually computing this on deep learning and NLP. Like, I'm talking in context of India, not I don't know about the global situation.
Yeah, I would say like the whole overall trend would be moving as like probably I think back in States, back in 2012 or 13, like a lot of momentum in computer visions, and then moving to speech computer visions, and moving to now, especially the past 2 or 3 years, it's a lot more NLP because of like probably Transformer, BERT, GPT-3, these kind of giant models, and NLP did have a lot of breakthrough, and also similarly for graph, because we have more and more graph data, and we have more and more compute. Like NVIDIA just released this like A100, it's much more powerful than their V100, right? So I believe as data and compute continues to grow, more and more giant model will come out that not our individuals can train ourselves. That would be, I feel like that would be a trend in general. Yeah, great question.
So, Rachel, it's just like not off topic. Like, how is the situation? Like, you're located currently you're located in US, right? So you can tell like because of coronavirus and all the other stuff. We had a huge elections also.
Yeah. Oh, thank you for asking. I should not talk about election, but right. But for the COVID, we have been working from home for like I believe it's like 10 months, like 9 months already, and it'll be continue at least until the mid of next year. So that's our current plan, and most of the other tech companies in Silicon Valley or in general states have followed similar plans. It's kind of super severe now because now it's holidays, Thanksgiving now as states, and the case is kind of it's like a roller coaster now. So who knows? How about India? How's the situation there?
In India, it's pretty much the same, I guess.
Pretty much the same. Most companies have given work from home orders till March of next year.
Yeah.
It's more until June of 2020, not exactly till March. Until I guess people do get vaccinated in metro cities of India. So they have extended it till June of 2020.
Can't be certain of anything.
No, just keep safe. Stay healthy. Just do more exercise. I feel like nowadays health is everything, right? With no health, there's like difference.
Yeah.
How's work from home feeling you?
I feel like it's a little bit different, but it's like similar to the graduate life or undergrad life. It's like you have to be motivated yourself. Like I feel like for most of I don't think it affects us a lot because we just need a laptop and a monitor and we can work anywhere, right? And I don't think it affects the tech industry a lot. But it did affect like the traditional industry a lot. Like the business is just slowing down.
Like apart from like working as a data science, like do you often freelance or work apart from like your own field, etc. In the field?
Freelancing?
Yeah.
I won't say I don't freelancing. It's like to be honest, our work is a little bit intense, and I feel like I still can learn a lot now as a junior scientist. So I don't freelance a lot, to be honest. Yeah.
What about the conversation between research versus job? Like this is a conversation that comes up very often when I'm talking about like the future. So many people wonder if you should focus on a research-based job or like a research-based career, or like maybe a teacher, or should you transition completely over to jobs, or should you find a balance where you're doing a job and maybe you're trying to build a platform where you can teach and try to become a teacher or a researcher for the matter of fact?
Yeah, great question. So I feel like it really depends on what you like. Try to do more research at school. So find a professor, find a mentor, and trying to doing like different whatever domain that you guys are both interested in, and get the feeling of doing research. For me, I tried it before. I tried it back to both undergrads and graduate, and I felt like probably I prefer industry.
Okay.
It's like I prefer more applied thing. Like I feel like industry, like you can apply whatever model on the real product, and it's kind of really engage other people, like to build a service, build a product, like to make it be useful. Like I don't think it's not like academia is not useful. It's like it's a long term useful. So that excitement is coming from like 10 years later.
Right.
So I would say I prefer like, applied science a little bit.
Okay, thank you so much. That answers my question.
So any other questions? I think at the time.